Good evening, everyone. My name is Decoy Green, and in this lesson, we'll be looking at linear differential equations, and we'll focus on complex roots. So we're going to try a question, and the first question states that we have d squared y over dx squared minus 4 dy over dx plus 9 y, and this is equals to 0, right? So remember, every time we're doing a linear differential equation, we're going to use the d operator form. So then we're going to change this to d squared y minus 4 dy plus 9 y, and this is going to be equals to 0, right? Seeing that y is common between all of them, we're going to factor out the y. So we're saying that we're going to have d squared minus 4d plus 9, and what we have left is going to have y is equals to 0 because we factor out the y, right? Next thing, there's something called auxiliary equation. Remember that with the auxiliary equation, we're going to change the d to m, and then we're going to equate it to 0. So now we have m squared minus 4m plus 9, and it is equals to 0. Because what we did is that we transferred the d's to m, and then so whatever is in here, we put it to m. So the d's to m, and we equate it to 0 for its auxiliary equation. Now we could see that we have a quadratic equation. What we need to do now is to solve for m. So in this case, we have to use a quadratic formula. So I'm going to go up here. And the quadratic formula states that m is equals to negative b plus or minus the square root of b squared minus 4ac, and this is going to be over 2a, right? So we're just going to plug in whatever it is. So we know that our a is 1, our b is minus 4, and our c is positive 9. So we're going to have minus a minus 4, so it becomes a positive 4, plus or minus the square root. B in this case is minus 4, but we're going to square the 4. So it becomes positive 16 minus, so we have 4 multiplied by a is 1, and then we're going to multiply it by c, which is 9, right? So we're going to say it's 9 multiplied by minus 4, and that is going to equal to minus 36. And this is going to be over 2 multiplied by 1, which is just 2. So all we're doing is that we're going to simplify. So m is equals to 4 plus or minus the square root. Now 16 minus 30. So when we say 16 minus 30, 16 minus 36, that is going to be equals to minus 20. And this is going to be over 2. So we're going to have m is equals to 4 plus or minus. Now the square root of 20, this is actually the same thing as the square root of minus 1 multiplied by 4 multiplied by 5. and this is going to be E over 2. So therefore, M is going to be equals to 4 plus or minus. Now, for this now, it's going to be 2 square root of 5i. I remember that it is going to be divided by our 2 here that we have here, divided by 2. So what we're going to do is that we're going to go on a new sheet and then calculate this. So we had that M is equals to, just go back, we had 4 plus or minus 2, 4 plus or minus 2 square root of 5i, and we had divided by 2. Now what we could do is that we could factor out a 2 in the numerator. So we're going to have M is equals to 2 open bracket 2 plus or minus the square root of 5i. And all of this is divided by 2. So what we realize is that the 2's cancel, and what we're left with is M is equals to 2 plus or minus the square root of 5i. Right? So now what we realize now is that what we're saying is that the 2 in this case is the real part and the minus 5 is the imaginary part. Why minus 5 is imaginary? Because it has an I beside it. It's being multiplied by an I. So remember, in order to solve a differential equation, we need 2 things. And we know that our general answer is y is equals to yc plus yp. So our yc now is going to be equals to, so seeing that this is a complex root, we have our formula. So the formula says that to find yc is e to the alpha x, open bracket, c1 cos beta x, it's going to be plus c2 sine beta x. So use this formula to find the complementary function if we have complex roots, right? So what we're saying is that yc is going to be equals to e, so the alpha is a real term, is a real part, and beta is the imaginary part. So alpha is 2. So it's e to the 2x, open bracket, c1 cos square root of 5x plus c2 sine square root of 5x. And this would be your answer for yc. However, what we need next, remember that our general answer should be y is equals to yp, well, yc plus yp. If we actually look back on the question, we get our yp from what is on the right hand side. However, there is no calculation to be made because this is 0. So therefore, what we're saying is that yp is 0. So our y will be equals to yc. And what is YC? What we've calculated here. So we're saying that this is our answer.